All right, one last little bit here in lesson 14 in Unit 3. Just looking at some of the mixed practice is what this is. So it mixed it all together. There's some addition of complex numbers, some subtraction of complex numbers, some multiplication, and some exponents. So this has started to mix everything all together. We should be able to accomplish all of these tasks. We've had some practice in each individual lesson leading up to this. And so here they're just kind of putting it all together so that we can acknowledge how to spot those differences. When are we adding? When are we subtracting? When are we multiplying? When do we have an exponent? And what do each of these mean? So for this activity in class, what we would do is we would split up into a partner, and you'd have partner A, partner B. And each person should work on their separate problem, and they should get to the same answer. And if they don't get to the same answer, they're supposed to talk through it until they figure out what the correct answer is and agree. So I'm going to be working row by row and doing both sides to confirm that we would have an equal answer in both places. Some of these are very quick. Some of them take a little bit longer. All right, so I'm going to start off just by numbering here at number 1. And I'm going to take care first at partner A off to the side here. And I notice that we have addition going on between two complex numbers. Remember that when we were adding complex numbers, we would add like terms. The real parts we would add together. So 7 plus 3 is 10. And then we would add the imaginary parts together. 9i plus negative 4i. So I have 9i plus a negative 4i, 9 positives, 4 negatives, add together to 5 positive i's. On the other side, partner B might be looking at this same kind or a different problem, and let's see if we can get to the same answer. This looks like distributive property 5i times 1 and then 5i times negative 2i. So I have a positive 5 times a negative 2, which is a negative 10. And I have an I times I, which is I squared. Now, many times over, we've written that I squared is actually equal to negative 1. So this is really 5i minus 10 times a negative 1. Negative times a negative turns it into a positive. So 5i plus 10. And we have a match over here, just in a different order. Remember, the real part should be first, so we should actually write this one again with the real part first and the imaginary part second. And now we have perfectly matching answers. So when you have this I squared, the I does completely disappear. It turns in completely to a negative 1 and turns that imaginary number into something very real, like 10. All right. First problem is done. Let's start tackling number 2. Partner A, looks like now partner A would have the distributive property going on here. So 2i times 3 gives us 6i, and 2i times 4i, well, 2 times 4 is a positive 8. I times I is I squared, and maybe you're already starting to recognize again, 6i plus 8 times a negative 1. We would have a very real part here of a negative 8, so I'm going to go ahead and write that first, and an imaginary part of positive 6i. I'm starting to go a little bit faster. So if you need to go back and slow it down to understand how these are changing and how that 8 times -1 turned into a -8, I'm just choosing to write it first. Actually, I need to write it first because the real part has to come first in our answer. On the other side of things, partner B has a subtraction of complex numbers. We are subtracting. So again, combining like terms, 1 minus 9 would give us a -8. 2i minus 4i. Remember, minus is enough to build a positive, so we have a plus going on. So I have 2i plus 4i, which would give us a positive 6i. It is already real first and imaginary second, and we have a perfect match left and right. So problem number 2 is done. I'm going to tackle number 3. I'm going to take that just down below over here. Now again, if you were in class, you would only be doing one or the other of these, so it would go a lot faster. But it's good to just have a good mix of practice going on. So I'm going to do 3, and first of all, I'm going to do partner A. I see 2 complex numbers, and they're being multiplied together. So this tells me I need complex multiplication using the grid. 4 minus 3i. And 4 plus 3i. 4 times 4 is 16. 4 times 3 is 12, and there's an I there. Here I have a -12 with an I. And let's see, a -9i squared. I squared equals -1. So a -9 times a -1 equals a +9. Doing some of these steps in my head, and some of this practice should be helping you speed that part along. So I have a 16 plus 9, we get to 25. And I have 12 positive i's and 12 negative i's. That gets us to a 0 i's. There is no imaginary part to our solution here. So there's partner A. Let's see if I get the same answer when I do the work here from partner B. Partner B has some addition of complex numbers going on, so I would add the real parts together. And I would add the imaginary parts together. I'm sorry, I should write it this way. Sorry. Gotta take my thinking with me. Positive I, and I'm adding a negative I, and a positive I and a negative I cancel each other out, and we have no i's left. Perfect match. Let's tackle number 4 together. Number 4, partner A has 2i in parentheses to the 4th power. This means that the 4 applies to both the 2 and the I. 2 to the 4th power, so I need to multiply 2 4 times over. 2 times 2 is 4, times 2 is 8, times 2 is 16. I to the 4th. Now somewhere in our past, in our history somewhere, we had I to the 4th, and we knew that I to the 4th equals 1. So this is just 16 times 1, which just equals 16. Partner B's problem may look pretty ugly, but once we start doing some multiplication together, we'll see that it's really not too terribly bad. I am going to set up some grid multiplication down below here. So I need a grid. And then one part of my grid, I have 3 plus I square root 7 and 3 minus I square root 7. Oh, my left-handedness is showing. Sorry, it's getting all smudgy. 3 times 3 is 9. 3 times negative I square root 7. Man, I wish I left myself more space. Negative 3I square root 7. And now I have 3 times a positive I square root 7. Oh, now I see. It's not going to be so ugly. Maybe you're seeing it too. And then in the last box, I have a positive times a negative, so it's going to be a negative. I times I squared, and square root 7 times square root 7. That is square root 7 times itself, so I'm going to make that squared. Now all kinds of things are about to cancel out here. So let's start here with what we know. There's still a negative in front. We know that I squared equals negative 1, and square root of 7 squared, well, square root and squareds cancel out, so we end up with 7. So this whole box equals negative 1 times negative 1 times 7. Negative times negative is a positive. 1 times 7 is a positive 7. Now combining some like terms in here, like we've done in our past. The real parts that we can combine together equals 16. My imaginary parts completely cancel each other out. I have a positive 3I root 7 and a negative 3I root 7. There is no imaginary part to this problem. So it equals 16. So far, so good. We're doing great. Alrighty, let's look at number 5. Partner A has some subtraction going on, so I'm just going to again kind of group my real parts and my imaginary parts like I had done before. I have a real number 1. I am subtracting negative 7. So 1 subtract negative 7. Subtract means to add. So these two total 8. My imaginary parts, I have 5 square root I minus I square root 5. Well, I have an I square root 5, and minus builds a positive. I'm going to add another I square root 5, so that should equal a positive I 2 root 5, or 2I root 5, or 2 root 5 times I. But I'm going to write it this way, just because that's how I want to write it. Real part, imaginary part, we're done. All right, so maybe I do want to just write it like 2 root 5 I. Just make sure that that I is not under the radical. Okay, it needs to be out front. Now part B, partner B, has multiplication going on. So they're multiplying negative 2I times negative square root 5. And then they're adding, because there's addition right here, negative 2I times a 4I. So we're distributing that negative 2I multiplication going against each of these two terms. All right, negative times negative is a positive. 2I times square root 5 gives us 2 root 5I. Ooh, there's a perfect match. I already know that one. That's pretty cool. And that must mean that over here I've got negative 2 times a positive 4. Negative times positive is a negative 8. I squared, but I squared equals a negative 1. So I end up with 8 times negative 8 times a negative 1, which leaves us with a positive 8 and a positive 2 root 5I. Now these two are the same, so we are good to go. Last but not least, hang in there with me. We've only got one more to go. Number 6, that very last one. Partner A has a series of fractions and i's all multiplying together. And when we multiply fractions, we can multiply straight across the top. Right? 1 times 1 times 3 equals 3. 2 times 3 times 4, well, 2 times 3 is 6. 6 times 4 is 24. And then we have I to the, let's see, we have 3 i's multiplying each other together, so we'd have I to the third. And we can simplify some of that. 3 does go into 24 evenly, so we can reduce that to a fraction of 1/8. I to the third, going to take a quick look at my little reference chart here. I to the third equals a negative I. So our answer would be negative 1/8 I. Let's see if partner B would get the same thing. Partner B from up above has 1/2 I in parentheses to the third power. So the third is applied to the half, and third is applied to the I. So I have 1/2 times 1/2 times 1/2 I to the third. Multiplying straight across, 1 times 1 times 1 equals 1. 2 times 2 equals 4 times 2 equals 8. I to the third is still a negative I. And we also get negative 1/8 I. So all of our values have matched up from our partner A and partner B. We've had some mixed practice here of everything from addition and subtraction, multiplication, multiplying two complex numbers together, and even using some things like exponents. Lots of great practice, and there's more waiting for you in practice problems for lesson 14.